Okay, hello everyone. It's me, Ariel, and I'm giving a presentation on the Chatelier principle, and it's all about shifts. So, um, the Chatelier principle is applied when there is a changing condition that displaces it from equilibrium, and the reaction shifts in the direction that offsets the changing conditions. So, essentially, the Chatelier principle mm, is when there's a change in a reaction's equilibrium and it wants to get back to equilibrium, so it'll shift in whichever way it has to return to equilibrium. And three factors that can affect the reaction at equilibrium would be a change in the reactant slash product concentration, reaction's volume or pressure being changed, or a change of temperature. So changing concentration. So increasing or decreasing the concentration of a product slash reaction will cause the reaction to shift in the direction that will return the reaction to equilibrium. So A2 plus B2 equals 2AB is the example. And so if you add A2, then the reaction would shift to the right and try to compensate for the A2 being added. If you add AB, then the reaction would shift left and try to compensate for the AB that is being added. If B2 is removed, then the reaction would shift to left and try to compensate for what is lost. So the Chatelier principle says that the shift will be in the direction which the change is coming from. So it'll try to make up for whatever is happening. And these are kind of like examples of how they would ask a question and like which they would say like if something is being added or something is being taken away and which direction it would shift and such. And so we're going to go on to the next factor, which would be reactions, volume, or pressure, of course, being changed. So the reaction is 2H2S plus 3O2 yields 2H2O plus 2SO2. So the amount of moles on each side comes into factor on which way the reaction will shift. So the pressure is being increased and then the reaction will shift right because there are less moles in the products than there are in the reactants. So by shifting the reaction right, then there would be a decrease in pressure because there are less moles on the right. Sorry, it took me so long to say. And so another example of this kind of shift would be if the volume is decreased. So if the pressure is decreased, then the reaction would shift left because there are more moles on the left. So shifting the reaction left means increasing the number of moles in the reactants, which would then increase the pressure and return to equilibrium. So this shift would also occur if the volume is increased. So the volume are also other ways you could ask about which way it would shift because volume and pressure have an indirect relationship, which means as one increases, the other decreases. So if volume goes up, pressure goes down. If volume goes down, pressure goes up. That's all it is. So we're going to move on to the next factor. So temperature is the last and final factor of the Chatelier principle, and it would be the example I did is heat plus N2O4 yields 2NO2. So this reaction is endothermic because heat is being added on the left side, which means it's positive, and delta H, whenever it's positive, is endothermic, and it shifts to the right as the reaction is being cooled. So I kind of like explain a little bit. So when the reaction is being cooled, then it shifts to the left since there's heat being lost. So there's heat on that side, but if the heat is being lost, then it wants to add more of the heat that's on the left side, so it'll shift left to increase heat because it's currently being lost, which is the change. When the reaction is being heated, then it'll shift to the right because it wants to lose some of the heat that is being added to return back to the point it is. And I have another example, which is exothermic this time because the heat is on the right, which means that it is negative. Delta H is negative. So N2O4 yields 2NO2 plus heat, so it's the same reaction, but heat. heat is switched. How original. So then when the reaction is cold, then it would shift right because, heat is being lost. So then it wants to increase the heat. So it'll shift rightwards. When the reaction is being heated, then it would shift leftwards, which means some of the heat that is being added. And it's just the opposite to endothermic. So it's kind of like vice versa. You just have to check out where the heat is being added and see what is happening, what they're asking you, and it's really not that hard. And that's the end of my presentation. I hope that this was informative and that you learned something because I remember I had a hard time with this shift and I honestly didn't know what this principle was called until the end of the year. So, I hope you get something from it. Thank you for listening and